Hey guys, I want to show you how you can use the graphing calculator to hack your way through significance tests. So I'm going to do it for this free response question, even though I'm going to caution you, do not use this hack on free response questions because you have to show all your work to earn full credit. But this hack is great for multiple choice. I just already have this free response question ready because I'm going to make a video going over it so that you have that resource to help you as you prepare for your test as well. All right, so this problem right here, if we're going to use the calculator to answer, I'm going to still need to find some information from the problem. So I'm going to give a rough setup and list all the information I have. A researcher conducted a medical study to investigate whether taking a low-dose aspirin reduces the chance of developing colon cancer. As part of the study, 1,000 adult volunteers were randomly assigned to one of two groups. Half of the volunteers were assigned to the experimental group that took a low-dose aspirin each day, and the other half were assigned to the control group that took a placebo each day. Right there, I see that this is going to be a 2 sample. Even though we have 1 sample of 100 volunteers, they were randomly divided into 2 groups. So this is actually an experiment that's happening here. N1, it says that they divide the 1,000 people in half. So N1's 500 and N2 is 500. All right, we'll keep reading. At the end of 6 years, 15 of the people who took the low-dose aspirin had developed colon cancer, and 26 of the people who took the placebo had developed colon cancer. Okay, so that tells me that in group 1, those are the people who took the low-dose aspirin, that there were 15 people who developed colon cancer. And in the second group, there were 26, the placebo group. At the significance level of 0.05, do the data provide convincing statistical evidence that taking a low-dose aspirin each day would reduce the chance of developing colon cancer? All right, so essentially we have this 2 sample here. The null hypothesis for a 2 sample always P1 minus P2 equals 0. But what we really need to focus on is the alternative. So we're looking for if this provides statistical evidence that taking the aspirin reduces your chance of colon cancer. So we want to know if P1 is going to have less of a chance of getting colon cancer than P2, which when we subtract them, that will result in a difference that is negative. So we're going to say is less than 0. All right, now this is the information I need. I don't even have to calculate P hat in order to do this. So I'm going to go ahead and open up my calculator, and we can go through and see how to do this on your graphing calculator. So I'm going to go ahead to Stat, and then I'm going to go over to Tests, and I'm going to go down to a 2 proportion z-test. This is option 6 on my calculator. It might be different on yours. Also, you'll notice right above it says 1 proportion z-test. So if this was a 1 sample, we would use that. But you have to make sure you're using the proportion, not the one that says sample. So we're going to go to the 2 proportion z-test, hit enter. Then it's going to ask for all these pieces that I wrote down. So X1 is 15. N1 is 500. X2 is 26. N2 is 500. And then we said this in your calculator, I think it usually says not P1 and P2, or it might say HA. So this is now looking at our alternative hypothesis here. We said that P1 minus P2 is less than 0, or another way of looking at that is that P1 is less than P2. So we're looking at that middle option here. So I'm going to hit enter. If yours is a little bit different, just think about what it looks like in our alternative hypothesis. And then you can skip the color because we're not going to worry about drawing. You can try to draw it and it'll show you a picture, but I'm just going to go ahead and calculate. And when I calculate, if I go up, I can see all of these different things that it tells me. So X1, N1, X2, N2, we put in there. But then what we've got, okay, there we go, is that we would have gotten, if we did this by hand, a z-score of negative 1.75. So if you're asked for the test statistic, that would be it. And then it gives us the p-value, which is 0.0397. And that would be the answer if you were asked for the p-value. It also even tells you what p hat 1 is, p hat 2 is, p hat combined is. So it gives you all of this information just by plugging in a few things to your calculator. So I hope this hack helps you as you are preparing to crush significance tests.